better than like, I mean, Miss Hollis's room, she plays okay, like music, but it's like that weird, like chill music that's like only instrumental and makes no sense. You know what? He's my favorite teacher because he listens to Pink Floyd. That's my hat's off to you, even though I don't have. More of a Metallica fan, really.
This next unit is there's a lot of stuff on it that's not going to feel very mathematical. I elected today to start with the non-awkwardy part. We're going to talk about functions now for a few weeks, and it can be a little bit abstract. I feel like I may have it figured out, like how to get it across to you, but some of the stuff we have to talk about with functions is, hold on a second. So anyways, there's a lot in this unit. You're going to hear words like domain and range and intervals, and it gets a little bit abstracty, but I didn't want to start with that today. I thought, oh, what a great introduction to the new chapter, something really weird and confusing. So I decided to go down and do some concrete math with you here for a couple of days, some mathy math. So anyways, the next unit is all about functions. And I'm just kind of warning you that it'll feel a little bit strange starting later this week and into next week. But for today, the math ought to be, I think, pretty pleasant, I hope. So when we talk about a function, you're going to see this notation right here, and we're going to practice saying this together. Anyone want to take a guess as to how you say that? I mean, that's such a random question. I get that, but like, say that again.
The function of x.
That's a pretty good effort on that. The function of x. The way you actually read this out loud is, and get used to it because we're going to say it like 1,000 times, is we say f of x. That was really a wonderfully good effort, by the way. So when I put something up there and write that, it's not like a multiplication. What it means is that we have a function. And by the way, the name of the function in this case is f. And what it is it's a function of x. And so when we read it just in passing, we say f of x. But what we're implying is that there's a machine somewhere called a function. His name is f, and he does math with x's. So when I define a function for you, the thing I'm about to write on the right side of the equal sign is called the function rule. And I could put a function rule like this. And what I want you to think of with functions is I want you to think of functions as little machines, and every function is defined to do a different job. Does anyone want to take a shot at what this particular function's job is? Functions do stuff. You always think of a function as a little machine that you feed it something and it goes like beep, boop, 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 and it vomits you out an answer. That's what functions do. You feed them, they give you back. What does this function do if I feed it a number? Let's just say that, and that's, again, such a strange thing to be asking you if you don't know what's going on, but if I put a number right there, what would this machine do first? Heck yeah, it would multiply whatever I give it by 3. But then it would say, I'm not done yet. I'm not ready to vomit out your answer yet, because then what else does it do? It subtracts it by 4. Correct. And so to evaluate a function is essentially just to feed it and then wait for it to do whatever math it does. And all functions do different math, and then it will an answer back out to you. So what it's going to look like when I ask you to do math is something like this: f of -5. That's how we read that. F of -5. And it's a very mathy way of just simply asking someone to please take the function, go find the function whose name is f, and into that machine, I want you to put all the x's, the input spots, I want you to change them all into -5. Huh? That's easy. So I'm going to take and I'm going to rewrite the function rule. You don't have to show a work like this all the time, but just to show you for your notes what it's going to look like, is I'm going to take and I'm going to rewrite the function as 3 blank minus 4. And you see that I put a blank where x used to be because it's waiting. And what's it waiting for?
Number to be put in.
a number to be put in. We call that the input. And so when I input a number, in this case, -5, now it's time to let the function do its thing. And all functions behave differently. They're all wired differently. They all have different inner workings, but this particular function is going to now do the math. What is 3 times -5? And what is -15 minus 4? So we say in conclusion that f of -5 is equal to -19. I'm going to write down something and I'd like you to jot it down as well. This number is called the input. This number, you guessed it, is called the output. And again, all functions, they're like little cute machines. You feed them and they spit you back out answers. That's what they do. And I have lost my little note card, which is not the worst thing that could have happened. But that's okay. So any questions so far? This is honestly what we're going to do today, is just evaluate functions. But I wanted to run through some different types of examples, some questions that could come up where you get a weird one and kind of say, like, what am I supposed to do here? So we good on the basics? Okay. And by the way, functions don't have to be named f. You'll see functions that are named all sorts of different things. Like I could name my new function g of x. And what I understand from that is that the name of the function is g, and he is accepting inputs of x. That's what he says. I'm a machine, feed me x's. My name is g. And the function can behave like this. Can you describe to me, just in plain English, what this function does? Like, how does this function behave? Like, what's his thing? What does he do? When I give him a number, what does he do? Yeah, but be a little bit, be more mathematically specific. What is the first thing this machine will do when I give it a number?
Add x to a number.
Nope.
Multiply x by -1.
Yes, now we're getting somewhere. You have to understand that in this little yellow bubble right here, there is a mathematical operation. It's going to change the sign of whatever I give it. So the first thing this function is going to do is say, I'm going to change the sign. You give me a number, I'm going to change it to its opposite. And then what's it going to do when it's done with that?
Add 15.
Then it's going to add 15 and spit me out an answer. Every function can be described like that in English. Change the sign, add 15, vomit out the answer. So if I asked you for something like g of -4, I don't really feel like I need to show work on this one, but if someone, put a gun to my head and said, I insist that you do, this is what it would look like. I would put negative blank plus 15. When doing a function, you essentially just copy the function rule down, putting a blank wherever it's waiting for an input. And what's going to go in that blank? -4. And you see, I've already got a negative placed from right there.
So we're gonna change this.
So that's what it does. A negative x just says, I'm going to change your sign. And what is the negative of -4?
Positive.
And what is +4 plus 15? So we say that g of -4 equals +19. Done. Okay. Any questions so far? Okay. Let's take a look at some different types of functions. You're going to see some functions that are called quadratic functions. And we don't do a ton with quadratics in Algebra 1. We will talk more about quadratics later on. But we give them a very, we get a small helping of quadratics in this class. But here's a little bit of a taste of what a quadratic looks like. So let's have a function named h of x. So again, his name is h, and he awaits x's. And his function rule is x squared minus 4x plus 3. Knock it off. Just once and for all. Keep writing. Keep the pencil moving. I'm not going to pause my recording anymore. I'm not going to use your name. Stay awake. I'm getting sick of this. Can you guys describe to me, just again, please, using plain English that anyone could understand, what does this function do when I feed it? Go ahead, Cal.
You're gonna
The S word.
multiply itself by 2.
Yeah, the word you're looking for is square, right?
You're gonna square it.
Okay.
And then you're gonna add -4 to it. Oh, no, add -4x to it, right?
How many inputs do you see?
Two.
I see 2 slots. And so maybe we should try a problem and then maybe you could describe it to me maybe a little better. Let's do an input of, let's find h of, I don't know, how about 5? Keep it simple. To understand that the more x's that a function rule has, that's just a little bit more input you have to do. This particular quadratic function has 2 input slots, and I'll draw little yellow arrows to them. One of the input slots is right here, and one input slot is right here. If you'd like a guaranteed way to always be successful with this, then just do what I'm about to do. Just copy, bless you, just copy the function rule down, but every time you see x, just put parentheses. So blank squared minus 4 times blank plus 3. All you gotta do is take the x's and swap them out for input slots. Some people don't like showing that much work, but that's just from me to you a good, almost guaranteed way to say, I'm gonna get this right. What's gonna go in those little blank spots? The 5, the input.
Oh my gosh, I did exactly
This
like
guy,
that.
just like this, is gonna go here, and he's gonna go here. Now let's think about the order of operations. In this problem, non-negotiably, what has to go first?
Exponent.
We got to do that exponent first, right? And what is 5 squared?
25.
Good. Could I also do this multiplication problem?
Yeah.
I could. It's not going to affect the other one because they're separated by that minus is like a buffer.
-20.
So I'm just going to put minus 20 plus 3. Look at what we just did.
And you're gonna
Then you
subtract
have
them
to
and
add them all together.
Yeah, left to right rule, right? Remember, do not add before you subtract. That's a lie. A does not come before S in the order of operations. A and S just go from left to right. What is 25 minus 20?
Five.
And what is 5 plus 3?
8.
So we say h of 5 equals 8. Done. Evaluating functions is pretty easy, huh?
Yeah.
Okay, I have a couple more, and I've just chosen these next examples because in my experience, these are the ones that people tend to mess up. For the record, I have 4 more examples on my note card. I don't know if we're going to need them all, but here comes the first one. So let's call this function f. Let's go back to f of x. And this function's rule is 3x squared plus 2x minus 11. Can you describe to me, maybe now that we've done one, you'll have a little more luck. Can you describe to me sort of preemptively in English what this function does? Go ahead, sir. Yeah, so once I do that, can you describe to me the inner workings of this function? What does it be? Just describe it to me in order. What's the first thing it'll do? It'll square x. What's the next thing it'll do?
It'll multiply.
It'll multiply whatever you get by 3. What's the next thing it'll do?
By 2x.
It'll multiply by 2, and then finally you'll add and subtract from left to right. Now we're cooking with bacon grease. Good. So there's going to be a whole bunch of operations that we have to do in the right order. So this time let's do f of, I don't know, let's do -2. Now, my pro tip for the day, take it or leave it, is this. 3 blank squared plus 2 times blank minus 11. What's going in those blanks?
-2.
The input, -2, is going to go into those blanks like that. The reason this example made it onto my note card last night when I was writing these is because you would be surprised how many people multiply these two numbers together first, right? Maybe you wouldn't be surprised, but it happens a lot. Why is that illegal? Because there's an exponent in the law of the rule, the order of operations isn't something that we like interpret on our own. Exponents go first. So what's going to get raised to the power of 2?
The exponent.
Just what's in this funny looking red cloud. Are we clear? This 3 that I'm pointing at with a little arrow, he could just wait his dang turn. Clear? So do not multiply early because the order of operations says you get that exponent out of there first. What is -2 squared or times himself? It is not -4. It is +4 because when you square a number, you multiply it by itself, and a negative times another negative is a positive. So this becomes 3 times 4 plus 2 times -2 minus 11. Any questions about that? Now, would you agree that I can do the little yellow island and the little purple island at the same time. What makes that legal?
Multiplication.
What makes it legal? The buffer.
Oh.
See that plus sign in the middle? He's a buffer. He says, you do whatever's over here, you do whatever's over here. I'm going to keep these fools separated while you do that. That's what pluses do. This is good. So what is 3 times 4?
12.
And what is 2 times -2?
-4.
And now we got ourselves a good old-fashioned 4th grade addition problem. Left to right, baby, right? What's 12 minus 4?
11, or
What's 8
8.
minus 11?
-3.
So we have f of -2 equals -3. Done. One more. Got it? Unless you want more, because I got more. F of x. But I was going to show you something, by the way. Just, I want to be clear, and you don't have to write this down if you don't want to, but like you can name a function j and have it be a function of m. So maybe this is what I'll do for this example, is just show you, like, functions do not have to be functions of x. They can be functions of whatever variable you're tinkering with on that particular day, and they can be called whatever you want. It's like if Chris Garcia was going to write a problem, he could call it C of G, and G could be his input variable, and he can name his function C because he's the boss, right? So I'm naming my function J of M, and the function is going to behave like this. This is a trick. This one's a little bit tricky. So here it goes. We're going to do a J of about 6. Ready? I'm going to mess up. I mean, I'm going to follow my own directions and do this first, but I'm going to do negative blank squared minus 3 blank minus 1. Nothing to it, right? Just following my own directions. What's going to go in those little funky blanks?
6.
So I'm going to put a 6 here and a 6 here. I'm about to make a mistake, so I wouldn't write this down if I were you, because I'm just telling you straight up that it's going to be wrong. But I want you to see if you can tell me why it's wrong. So here I go.
You forgot the negative.
Yeah.
in
Wait,
front
I
of the
squared it.
36.
I squared it.
You forgot the negative in front of the
I squared it. What's -6 squared? What? When you square a negative, don't you get a positive? Say that again. Yeah, good job. And you guys were all tag teaming me and saying the same thing. Good job, you guys. This negative, I'm gonna use a little yellow symbol here. This negative is not part of the squaring process. I'm going to say that again. The negative is not part of the squaring process. He was already in the problem long before we put stuff in. So he looks at you and says, save me for last. Well played, well spoken back there. The negative is what we call an afterthought. So I take my whatever I put in parentheses and I square it and I get 36. Yeah, but then that negative sign, he's like, hey, don't forget about me. You guys were all over that like white on rice. So watch out for that. Don't fall for that trap. When there's a negative in front of the x squared, it's an afterthought. It's going to stick around whether you want it to or not. And now we can do the math. What's -36 minus 18 more? And what is -54 minus 1 more?
-55.
So we can say that J of 6 equals -55. How do you feel? You feel like you got this? You think you can do it? Do you want another example? Okay. Your assignment is on Delta Math. I don't think it's going to take you all that long. I do apologize for the limited time. You're down to like under 10 minutes, but I bet you could get like 15 problems done in 10 minutes. So I'm going to keep this going, but paused in case anyone has any questions.